Chris already introduced the subject, so I'll just dive right in. I wanted to start out with a survey, some results from the industrial space, from the IoT Institute. And they were talking about what are the inhibitors in terms of cloud adoption and what is stopping people from adopting it more broadly or comprehensively. And it's interesting that the top two concerns are about security. The first one is just security in general, and then data privacy in particular. And I talked about some of the other things in my discussion yesterday, if you want to look it up, but let's dive into security for today. I think that these concerns at some level are well-founded. If you look at a lot of the press clippings, of course there's hundreds of these, I selected a few for this talk. And one of the things that we're finding at Mentor is that more and more of these are becoming, say, industrial focused. And in fact, 3 of these, if you start on the top left, there's some warning there from US CERT that there are specific ongoing cyber attacks that they're knowledgeable and aware of against industrial infrastructure. And particularly they're talking about critical infrastructure in the US. If you look at this one on the top right, it's kind of interesting. This is a fairly broad survey of small to medium manufacturers. And the 2 main takeaways from the survey that this publication did were that, first of all, that they had a very positive outlook on the economy, which is good for all of us, but the others is a lot of cybersecurity concerns. And the thing that really caught my eye in this particular one is that over a third of the companies that had been surveyed actually had breaches. Not that they were attacked, but they were actually breached by a cybersecurity attack. And in fact, I was at ARC Forum in the spring. I was talking to a person who's responsible for a large petrochemical refining plant. And I asked him about cybersecurity and how often he felt they were attacked. And I thought he was going to say multiple times a year, perhaps a month. He said multiple times a day that one facility is attacked. So this is a very prevalent issue that we're all dealing with. There's also a research study by MIT down here talking about the ongoing attacks. And then the one in the bottom left is the crack attack, which is a general Wi-Fi one, but there's a lot of Wi-Fi. I was just looking at a device downstairs that's using Wi-Fi. It's kind of a generalized vulnerability for that. So there's a lot of danger out there, or concern, things to be concerned about. And so now let's talk about how to deal with that. And when I think about security, I think about it in basically 3 levels. There's starting at the device level and protecting the device. It shows a firewall there, but there's much more to it than that I'll get to in my talk. And then we think about it in terms of the site, maybe the automation system, the factory. And then now with the cloud and the use of MindSphere out there, you have to think about it more globally. I'm going to focus mostly on the device and secure connectivity with MindSphere today. So first of all, with the device. Security does begin at the device level. There's an interesting white paper, by the way, from the Industrial Internet Consortium that talks about this. And I took a quote of it for this presentation, which you can read there, but it says trust flows from the owner-operator down to all parts of the system, but it must be built from the bottom up. And by that, they mean from the device. You have to start at the device. And also, many people in the past maybe have thought that perimeter security, securing their production facility, might be sufficient. But there is some generalized information out there. It's maybe more from the enterprise world, but it shows that most attacks actually come from within the enterprise. And there's also some government mandates about securing the device, especially for NERC, for the critical infrastructure, and endpoint, or end device as we call it, type security, which we'll talk about. If I think about it then in a little bit more detail at the device or the infrastructure level, there's really 4 different categories of security that can be addressed. I only have time today to talk about the latter 2, but I thought I would show them all at a high level. The first one is comprehensively supported by MindSphere itself, which is a secure onboarding of the device. So that's the generation of the device identity and then allocating those secure assets to the device. Of course, you have to protect them on the device, which we'll get to at the data security element here, but then also the interaction, the onboarding, and the communication management to the device. So MindSphere has a great solution in that area. I'll leave it for them and the other talks to cover that. Configuration monitoring. This is just another way that you're interacting with the device. So anytime you update the device with new parameters, you configure it in any way, shape, or form, you're touching the device, you have secure access to the device. Of course, you have to secure all those interactions. There's some similarity of that to one of the things I will talk about on data security. And really, I break that particular topic down into 3 subtopics, and looking at data at rest on the device and securing and protecting that. Data in motion, one example of that would be telemetry, sending data up to the cloud. and then also data in use in the applications, computationally used on the device. And then software updates in particular. I think it's really become an expectation in the market that devices are updated and maintained, in particular for security vulnerabilities, but also with new features, bug fixes, things like that. And that has a lot of complexity anytime you're updating the software on the device. So I'll talk about that as well. So first of all, data security. So I talked about the three categories on the other side. If we just walk through those a little bit. So data at rest. It's really about accessing or controlling access to the device. So generalized access control, who's allowed to communicate and do any level of access to the device. Typically a firewall would be used, as I mentioned earlier, but that's only one aspect of the solution. And I would say anti-tamper monitoring, intrusion detection, and anomaly detection. Not for physical differences in the machine, but for computational differences that can be indicative of malware that may have been penetrated on the device. So those are all key areas for securing data at rest. And then at the top there, you see having a secure boot strategy is also critically important, because that actually makes sure that anything that executes on the device is actually properly signed and is meant to be there and is not some form of malware or unmonitored computational element. If we move down to data in motion, once again, telemetry is an example of that. Of course, proper use and configuration of all the standard security protocols. There's many of those that are out there, but if they're not utilized or configured properly, they don't give you adequate security. And then when you're talking about data in motion to the device, basically a software update is an example, then encryption and authentication of that. And I'll talk a little bit about the mechanisms that can be used for that. And then one of the things that we really propose to our customers is looking at Achilles. It's not really about data in motion, but it is 100% focused on the TCP/IP stack and essentially the communication protocol that you use on the device. And it's a very robust set of tests for attacks that can be made against industrial equipment. So I always try to recommend people look at that and utilize that as well. And then data in use. So this is what the data that is being used in the application level or in other forms on the device. And a lot of the security that you can do there comes down to separation. And this is basically separating applications or computational elements on the device. Sometimes what you want to do is take the communication software and separate that out from other things that might be doing, even control systems, but maybe have access to other critical data, or can otherwise affect the machinery, for instance, that's being interfaced with or controlled. And there are different ways to do that, kind of starting from the easiest, and maybe the least level of separation is just using a secure process model or even any type of process model. Containers and the Docker infrastructure can give you a little bit more separation of these runtime elements. And then taking it to the greatest limit would be some type of virtualization, virtual machines, and a hypervisor to actually separate. And that will hide not only the applications and the operating systems, but also resources on the device from each other. So there's a significant level of separation and therefore security inherent in the use of a hypervisor. In terms of, that's all software solutions. Hypervisors, of course, they use hardware on the device to enable the hypervisor and the separation I just talked about. But there's another form of separation, and ARM Trust Zone is a good example of that, where you can actually set up a secure world and use hardware elements on the chip to execute certain software in secure world and then separate that from what's called normal world. And normal world can absolutely see nothing that's going on in secure world. So it's a very high level of separation and can lead to very enhanced security on these devices. If any of you have your smartphone, probably everybody here has, if you want to stream high-speed, high-definition media on your device, then actually the licensing of that to the streaming companies, which could be Netflix or somebody else like that, actually requires from the studios that generate the content that they use Trust Zone and they use this particular approach, because that's the only way that they will let their high-value IP get out into the marketplace, because they feel like it cannot be hacked and therefore people cannot get access and then redistribute their very costly intellectual material. By the way, in terms of our solutions, we have a booth right over here where we're showing some of these solutions, and everything on this chart is available from Mentor Graphics with our runtime software, with the exception of anti-tampering. We have a partner solution for that, but every other element of this is addressed in our runtime solutions. If we talk just about software updates, and there's a lot of different kinds of software updates, But it all starts with how you package the update. And we have products that are available that you run on a PC or wherever you create the software update, where you would encrypt it and you would digitally sign it. And then you upload that to MindSphere. And then MindSphere takes care of the download and the interaction with the device, which it has securely onboarded to MindSphere. And so that's the cloud backend. And then there are different use cases in terms of the types of updates. Kind of the simplest ones are application level updates, especially if you're using something like Docker, because then you can download that. You can use Docker Compose or other management software, middleware on the device that allows you to then implement that to instantiate the update and to execute on the device, even without a reboot. Of course, the reciprocal of the work that you did in terms of encryption and signing has to be done on the end device, so you have to authenticate it and decrypt it. We have support for all of that in our solution. And then I think the more interesting and certainly the more complex example is when you're going to do an update to the operating system, the firmware, or even the bootloader itself. In that case, it's more complicated. Once you have the validated and decrypted information, you have to interact directly with the bootloader. Of course, you can't just boot the system, reboot the system at any arbitrary time. You have to do that during maintenance or when instigated by an operator. But once a reboot does take place, it has to be done very carefully, and then you have to have health monitoring to make sure that you didn't in any way affect the functioning of the device and decrement its capabilities in any way. And if the health monitoring detects an issue after the update, it has to have the ability to roll back to a previous version. And we have all of that infrastructure in our solutions as well to enable the device manufacturers to build these very, very secure devices that can interact with MindSphere. One other thing that I wanted to mention, it wasn't on the list earlier, but just when we talk about security, we like to do a little bit of education in the market. There are two other things that should be considered, and I only have 2 bullets on here. It's a whole topic in itself, but development processes for secure software. I'd just like to highlight that your coding standards should have security in mind, and your developers should be trained on that. And then there are really good static code analysis tools out there that are specifically focused on security vulnerabilities. We use all of those in our development. I hope everybody else does. If you don't, you should look at them. That's kind of the infomercial. If we move on to the maintenance piece, then when you have a deployed device and that there are identified security vulnerabilities, maybe in the Wi-Fi driver or in the communication stack, protocols, whatever it might be, in the operating system itself, even in the compiler that was used to compile the applications or the operating system, there can be security vulnerabilities in the libraries with the compiler. So somebody has to monitor all that. You can do it yourself. We actually offer that as a service to our customers. We have engineers who monitor that multiple times a day. We monitor US CERT. There are other agencies that can be monitored as well. And then we categorize all of the issues that could be effective of the software we deliver to our customers. And if necessary, we generate patches and we make those available for deployment to the devices. So all part of the service that we have. This is my wrap-up slide. I didn't really talk about our products very much since the topic here was security, but we do have a Mentor Embedded Linux, which is used on large-scale devices, industrial devices, and edge devices for communication with the cloud, and then a real-time operating system, the Nucleus operating system. And everything I talked about earlier is available for these devices, for these operating systems. And then we have a broad set of mostly partner communication protocols, multi-core capabilities, hypervisor capabilities, and all those various types of things. So I thank you very much for your time. I hope you found it instructive, informative. Thank you. Bye.